Hello, flat earth researchers, debaters and debunkers. I'd like to try and clear up some confusion about what is considered scientific observation and the difference between that and measurable proof, which is something that we should have if we are to believe in the physically impossible spinning globe Earth. But we don't. We only have observations that are interpreted into a preferred hypothesis or some kind of proof, just because we can make a repeatable observation. So we can do something like take a ball and we could measure its size, which we'll do in a minute, and we can measure its weight. That is some kind of measurable proof of its size and weight, or its mass, if you like. Okay, but concluding anything else other than its size and weight from what we can actually physically measure is simply an interpretation, and at the most you can form a hypothesis, but it doesn't. That's not in any way scientific. So, for example, if I just then we got the sun about to set over there. Now, of course, this ball is tangible. We can measure the size of it. The sun is intangible. We can make an observation about when and where the sun will appear, and we can make predictions for that, and that would be maybe translated as being scientific. Oh, sorry. Because you know, we're making observations that are so-called repeatable. Just got to move out the way of these neighbours who are trying to park their car. Okay, so here we have a ball that we know. We can know the measurements of, the physical dimensions. We can produce measurable proof of a guess that we make about this ball. The sun? Is there any way of determining what is measurable proof about the sun? What can we really determine about the sun? We can make predictions about where it will be. We can make observations, and we can even observe that this tiny ball here will block off the sun. It doesn't mean anything, does it? It doesn't mean anything about the size of the sun, because we have absolutely nothing to base it on. We don't actually know the size of the sun. So this cannot be scientifically verified. The size and the distance to the sun cannot be provided as any kind of measurable proof. There is no measurable proof of the size and the distance of the sun. And either way, looking up to the sun certainly doesn't determine the shape of the Earth. Yeah? So, yeah, this is an observation. We can make an observation that this ball will block off the sun. Doesn't mean anything. It's just perspective and angular size and all that jazz. But we don't know the size of the sun. We don't know its angular size for us either. Yeah, really simple. Here's another observation. A candle, which is right in front of us. And of course we can make it appear to be the same size as the water tower over there. All right, now if we know what a candle is, we know its approximate dimensions, and we know the distance, etc., then sure, we can make some calculations and we can call that some kind of measurable observation. Yeah, but we can see just from doing something like this that it is all open to interpretation. So if you compare that to doing something like this, where we simply grab a tape measure, yeah, and we measure the length of the candle, then okay, that is measurable proof. Okay. Yeah, this is measurable proof. Yeah, we're making an observation of something that we can measure, but again, is this? I mean, okay, here's a good example.
my fingers appear to be as wide apart as the candle, but in reality they're 4 inches apart. Yeah, I'm only a few inches away from the candle itself. Yeah, so what does that tell us about an observation? You know, observations are completely open to interpretation, and of course depending on what we're told about how far away something is, how large it is. Yeah, but this is the measurable proof here, based on something that we've decided is a standard measurement. Yeah, measurable proof, that's the difference. So, you know, there's an observation, and we can guess the distance and the size of the candle, or we could just make a mathematical model to describe what we're seeing and say, oh look, yes, okay, well this is the angular size here at this distance and that distance. Yeah, sure, you can make up any kind of mathematical story, or what we call scientific explanation, but until you can actually go to something and do this with it, that's when you actually have measurable proof. So looking at the sun, moon and stars and attempting to determine their angular size or distance or their true size is completely theoretical. Absolutely, totally theoretical. And yes, you can make models from it, but they mean nothing. They mean nothing. Just because you can make predictions, it still doesn't mean anything about the true nature of what we're actually observing. So let's have a look at some more ideas of measurable proof. Got my nice scales here, and this is, it says on here 10 grams. Well, there's two 10-gram things. Let's see. All right, not bad. 20 grams. So now we have measurable proof. This is measurable proof that this does actually weigh 20 grams. It is what it says. All right. We've got some peanut butter, and although it's entire, you can see that it says 170 grams. We put it on the scale. It's not, because half of it's been eaten. Yeah? Okay, so the same applies to something. If you imagine this is the globe, Earth, and we're told that it has a certain mass and density, and this is what causes gravity. Can we do this to the Earth? Can we weigh the Earth to confirm the model? Of course we can't. So we have no measurable proof. Have no measurable proof of the idea that even when we do this, the only measurable proof that we have of this having weight is this. Anything that assumes there is an external force pulling it down towards the center of a spherical Earth is just that. It's an assumption. It's not measurable proof. All we have is this. Yeah? That is all we have. A measurement that we've decided to use as a standard, and weight. The cause of that weight is simply the fact that this is a dense thing in the air. To assume that this is caused by any other force other than the mass itself is an assumption. So that's not, even this is an observation of a measurement, but doesn't prove anything other than what we can see here. Yeah? So that's as far as the science goes. Just being able to record a number for this weight here. Yeah? And just one other thing I wanted to point out that I find rather funny. So it's funny how that when we take something like this and we measure the radius or the diameter, okay, so we got what, something like 6 centimeters there, okay, and then we take something like this ball, and I'll find the seam. Where is it? There it is. Okay. From there up to the top, I don't know, something like 9 or 10. Okay. So it's funny, isn't it? They refer to the globe's radius, which has apparently been worked out by observing the sun. Yeah, but we have a radius for a ball, and we have a radius for a disc. So this could represent the equator on a flat Earth. Doesn't have to be an equator on a ball. Yeah, again, it's all a matter of interpretation. They call this a radius, and they call this a radius. So, you know, what's the difference? We make observations and measurements, but they don't prove anything to the shape of the Earth, or where the Earth is in space, how it all works. So don't assume that we have a working model based on measurements or observations. There is no measurable proof. All we have are observations and interpretations. Yeah? Ball or flat is a matter of interpretation.
And just to add a quick addendum to this about interpretations of observations versus measurable proof, we can see that the sun has just set over there where I was watching it. Now, if I turn 180 degrees, we now have the moon rising. Nice, I think it's a full moon tonight. Okay, so yeah, that's risen up almost opposite the sun just after it's set. So we can make this observation and we can make predictions. If we observe the sun and moon every day for a year, we can then make predictions. There are no models that are exclusive to making predictions. We often hear people say, well, go ahead and predict the next eclipse. That's just based on record keeping over millennia and making predictions from those records. It has nothing to do with any kind of model. So there is no model that's exclusive to making predictions. And we can interpret this observation in all manner of ways we want to, if we want to create a model and then make up explanations to go with that model. We could say, well, the moon is, yes, we can make a globe Earth heliocentric model. But I could also say, if I wanted to, that we are orbiting the moon. And the moon is going to follow the same path overhead. It's going to set over there just as the sun did. And they are the same size. So what about these explanations and stories that we are given? The observations that we make of the sun and the moon are very, very similar. In fact, observations I've made here and in the UK to see this apparent rotation of the sun and the moon. They both behave in exactly the same way. The sun and the moon behave in exactly the same way. Yet we're told that one is 93 million miles away and we are orbiting it, and that the moon is a fraction of the size of the sun and a fraction of the size of the Earth, and it's orbiting us once a month. Yet we will see the moon come overhead every day and follow the same path as the sun. So how that is interpreted is really dependent on what kind of explanation you want to give for your preferred model or your hypothesis. Again, this is an observation. There is no measurable proof. Yes, it's a repeatable observation, and we can make predictions, and you can call that science to an extent. But there is no science to measure the physical distance to the moon. There is no science to determine the actual size of the moon. Again, I can stick my thumb up and block off the moon. Doesn't mean a damn thing. Yeah, it's just this again, it's just angular size and perspective. Same as we did with the sun. So it tells us nothing. These little things that you can do and make observations have no bearing on providing any kind of proof of any kind of model. All right, thank you very much.